random variables. So basic idea which we need to have about regarding random variables is that random variable is not a is not a variable. In fact, it is a function. So what does a random variable do? We have a probability space sigma fp. This is our probability space. Okay. A random variable, what it does is it takes the probabilities of the space to a new space R P P X. This R is a real line, B is actually a Borel sigma algebra, and Px is a new probability which has been assigned. So we'll talk more about Borel sigma algebra later, which is not too much in the scope of this course. And how this Px is defined. Px is, so we already, so where any event, any event which is already in F, which we belong to, or we can say which was a subset of F. An event which was a subset of F will get mapped to B. B is actually a subset of the real line. Okay, so probability of any event B, this is same as the probability of a random variable belonging to a Borel set B is the probability of all omega. Omega is the outcome which is belonging to the sample space such that x of omega belongs to B. Okay, hope this idea is clear. So here one thing to notice is here omega is actually um, the sample space and f is the set of all events. So ideally f is a subset of 2 raised to omega or the positive omega. P is the probability assigned for each event. So this is what ideally random variable does. Okay, we're not going too much into discussions of the Borel sigma algebra. But what we need to understand is, let's do something very basic. See, suppose we have a sample space, right? It has a set of omegas. These omegas are all the possible outcomes of any, um, all the possible outcomes. Okay, so an event F can be constructed taking a combination of these outcomes. It can be like omega 1, omega 2 set, omega 1, 2, or it can be also like a set of omega 4 and omega n. It could be a null set. You can take all the events together. All these possibilities are there. So probability ultimately we are defining it for a particular event, right? And in Borel sigma algebra, so Borel sigma algebra, yeah, just before that, while we are transforming the space to real space, omega is getting transformed into R. We are mapping it to the real line. So ideally we should have 2 raised to R as the transformation of F. But this is too big a space to consider. So what we normally do is we take a Borel sigma algebra, which is a subset of 2 raised to R, and we'll deal with events in that Borel sigma algebra. Okay. So what a Borel sigma algebra by definition is, Borel sigma algebra is the smaller sigma algebra containing all intervals. Sigma algebra has to satisfy few conditions, and that is not currently within the scope of this course, so we are neglecting that. Okay, so what are the key takeaways from here? So what is a random variable? Random variable is a function which takes events from a particular property space and maps it to the real line. And similar to what we have for any event, we have a probability. Similarly, once for a particular random variable, we have a probability of that particular random variable, which is known as px of p, which is the probability of x belonging to the random variable x belonging to that particular Borel set p, which can be written as p of all omega belonging to the capital omega, the sample space such that x of omega belongs to the Borel set.